Today we are going to see how to print any factorial of a number using procedure in assembly language. Okay, so if you are familiar with printing the factorial of a number in some high level language, which I'm sure you must have done it many times, so keeping that factorial in mind, you can do this very easily. So suppose what is basically a factorial? This is the factorial of 6. See here, 6 multiplied 5 multiplied by 4 till 1, right? The factorial of 3 is 3 into 2 into 1, like this. Okay, so now in assembly we have to analyze this multiplication carefully, that what is going to be our logic for this factorial, right? So see here, we know you can see that I'm moving 6, right? I am going to print the factorial of 6 on the screen. So for that purpose, what I need in the logic, you can see, you can also take input from the user, that how many times he which factorial he wants to print. Okay, I am declaring here n as 6. So here you can see I am performing this multiplication 5 times, that is n minus 1 times. Of course these total numbers are you can say 6, but you can see that this is my first multiplication, second, third, fourth and fifth, right? And we know that for this continuous multiplication, suppose user enters 10, so I need to multiply 9 times, right? So we need loops for such situations. So we know that for the sake of loops we use x86 register, right? So what should be my value in x86, like how many times I have to continue my loop, right? Because you can see that here my total numbers are 6, but my multiplication is happening only 5 times. So I cannot, you can say, of course I'm going to move 6, which means that I'm going to multiply these things 6 times. But see, if I multiply these things 6 times, that is one more time if I multiply, then it will become 1 into 0, which will just wipe out everything, right? And we don't want this, but still we have to move 6 in x86 so that my this last number also gets multiplied, right? Although it's not compulsory that you multiply 1, you can also move n minus 1 if that works out for you. But what I am going to tell you is that as I will move 6 in my, or you can say n in my x86, but as soon as this multiplied by 0 will arrive, I will put a, you can say, conditional jump over here, that as soon as 0 arrives we have to come out of the loop and simply print the factorial of that number till 1. I will not allow the compiler to multiply by 0, rather I will just make it come out of the loop, right? So this is the logic. So here you can see we are taking the declaration of our function, that is this one. So this here I am calling my function, and inside my factorial, what I am doing, you can see this is the procedure definition. So we know that we need some variable or register to store the factorial, right? So I am using ex for this purpose, and I am you can say that moving 1 in it so that there is no any garbage in ex, right? And after that I am moving my value is containing what? This n, that is 6. I am moving 6 in e6, that means my loop is going to work 6 times. So here my loop begins, that is this is the label. Inside the label, what I am doing, I am comparing e6 with 0, and as soon as this becomes 0, that is this e6 is 0 after decrementing each time of the loop, then we have to go where? We have to jump to the end. Jump if 0. If it is 0, then you have to jump to this label. This is the name of the label, right? Over here you have to jump, you have to stop this loop and come out of the loop. Otherwise, if this condition is false, that is in this case this is false, my value is 6, so my e6 is also 6, e6 is not 0, so we have to skip this statement and we will multiply e6 with eax. We know very well that how this multiplication statement works. This is how it will actually work. ex equals ex multiplied by e6. My ex is what? It is 1 right now. My e6 is 6. 6 multiplied 1 is 6, right? So my EAX is containing the result of my multiplication, that is, it is acting as a factorial variable, although it is a register, but it is acting for factorial storing, right? So after once we have to again go inside the loop. It will again check that if my 6 is 0. No, it is not 0. We know that we have performed this loop once, so our E6 decrements automatically. So now my E6 has become 5, right? And if 5 equals 0, no, we have to skip this statement again, and now we have to multiply 5 with EX. EX value was previously what? It was 6, right? So 6 multiplied by 5 is now stored in EX. It will again go inside the loop. Now 6 becomes what? E6 becomes 4, because each time the loop iterates, E6 gets decremented automatically. Okay, so now my E6 becomes, you can say, 4. 4 is not equals to 0. We have to multiply 4 with whatever was the recent value of EAX, and that again gets stored in EAX. Now again go inside the loop. E6 becomes 3. It will again continue, it become 2, then again 1. Till 1 it will work, of course. But when the 6th time I enter this loop, now I am entering this loop for the 6th time. Now at the 6th time my E6 becomes what? It becomes 0, right? So as soon as my 6 becomes 0, I had told earlier that I have to move 6 in my E6, but it does not mean that I have to perform multiplication 6 times, otherwise our result will vanish because of 0. So as soon as it becomes 0, that is the 6th multiplication arrives, I have to stop my loop. That is, E6 is 0, jump if 0. If it is 0, then you have to jump out of this loop, that is, you have to come at this level. Then the multiplication will stop, and our EX will contain the result of this multiplication. Factorial of that number will be displayed in EAX, right? And this return means we will return back to our main procedure, and by this call write int, whatever is in EX will get printed on the screen, and our EX should contain, you can say, 720, because I am moving 6, so its factorial is 720. So let's run it. If it works. So here you go, this is 720. So I hope you have gotten it. The logic was very easy, just you have to take care of that. You have to move that number in it in the E6, and you have to stop the loop as soon as 0 arrives. That's the main logic. Okay, so that's it for today. Thank you.